Hello again, Tom from Every Step Calculus, everystepphysics.com. This is a line integral in my 25 years of studying calculus. Is one of the most pathetic of all the systems here, the puzzles that they give you. Puzzles, I'm going to emphasize that, puzzles. And if you don't believe me, go online and see what they say about line integrals and how and what different professors say what it does, you know. But anyways, let's do it. Index 8 to get to my, oh, by the way, he sends me this is an actual problem that came on a study sheet for him to study for the next test, okay? And he says that some of the things go off the screen here when he does the problem, and that these kind of problems are on a lot of his tests or quizzes that he's taken so far. I say, if it is, nobody's going to pass it, nobody's going to do it. It's too difficult for anybody to do, so therefore it wouldn't be on a test. It's for homework and for the study material to try to make the professor look like they really is a genius at this stuff, you know. So anyways, index 8 to get to my menu. I'm already at line integrals to save time. You're going to hold the second button down and press the down or up to get to my menus quick, because there's 136 items in this menu, you know, for calculus, so that you can pass your class. And here we got x, y, z here, so we look here, oh, we have a function here, x, y, z, so let's choose that, number 5, okay? And then we're going to enter the function. We have to press alpha first before you enter anything in these entry lines here. Remember that, alpha, left parentheses, x plus y plus z, right parentheses, divided by the number 5. Okay, let's check it. Yeah, it looks pretty close to what's up here, doesn't it, huh? So that's good. We're going to say OK. Oh, what do we got here? We got x equals, and there's a t, x and a t in here, so in my programs we go for 3 of them, x, t, y, t, z, t. Here they are, x, t, y, t, z, t. Number 5 again, press number 5. It's not too difficult, is it? And we're going to enter what they've had up. Now, I've already entered these to save time, so I'm going to go through them quick, and here they are, okay? All these I've entered here. And I say that's okay. Now we're going to enter the range, and the range is pretty difficult too. Look at this range from 0 to 5 pi over 4. Couldn't make it a little bit simple, could he? Or she. It's a lady professor, I guess. So here's the situation for the range for t. I say it's okay. We start doing the problem. We have the RT, which is, and then we take the derivative, which is here, y, and then the derivative is here, z, derivative is here, okay? Now how many of you could take the y here and find the derivative of this, huh? Could you do that? I don't think so, unless you studied it. I couldn't do it right now, you know. So keep that in mind when you're doing these supposedly simple problems that are supposed to be on a test. It's not on a test. They have to be simple. You can't do this kind of stuff in your head. The ds here is equal to the magnitude of the derivatives of the RT, you know. And that's, the formula is square root of x prime, you know, the derivative of x squared, derivative of y squared, derivative of z squared, okay? So we do that, and we come up, put these variables in here. We're going to square them now. How many of you could square this? Could you square this right here, these two right here? We can square 3 and come up with 9, I guess, but what about this one? What about this one? Could you do it? No. Well, here's the squares right here. Here they are, okay? Now notice that it comes up to a nice little, convenient little solution of square root of 25, which turns out to be 5, of course. We all know that. Here's square root of 9. So these two here, when you add them together, must be the square root of 6. Now you tell me how they got that or how you get that, okay? Can you do that? No. So nobody would pass it on a test, okay? So now we're substituting these t's that we first got here, these 3t cosine of t, notice, and we're going to substitute them all into here. Now the calculator does the quotation marks, but you're going to put parentheses if you want to substitute it in here. But notice that this is for z, and this is for y, and this is for x over here, but it's off the screen, notice that? But still, you should be able to, I don't know, substitute these t's right here. What's missing? The 3t, so plus 3t in over here, okay? From 0 to pi, there's the range of the t's, okay? Now we're going to integrate. How many could integrate that what we just saw? How many could do that? Huh? Remember, integration is you can do each one with the plus signs between it. So here's the total integration of this, which a calculator miraculously does. Now I've separated it because this would be way off the screen here, all the way over here, if I didn't. But I have a program, or I programmed it so that if you get 17 characters here, which is 17, is going to divide it up and make another line of it, okay? Now I wish I could do that for everybody. I can't do it for everyone unless I know the problem and actually do it for that. And here's the range over here, the integral. Now notice here, this is 5, this is at 5, that ds here, which we just, you know, the magnitude of the derivatives squared, and that's came up to 5, remember that? So that has to be multiplied times this stuff here, okay, in here. So that's what I'm going to do now. And I did that, and here's the answer right here, okay? Now we're going to substitute t in here, 5 pi over 4, the upper range, and for all the t's in that integral, okay? And it turns out to be this right here. Now we're going to substitute 0 for all the t's in there, and that turns out to be minus 25 over 4, okay? Remember, in physics or calculus, upper minus lower, okay? Upper minus lower. Notice here's a trick here, minus a minus 25. You'd have made a mistake on that, and you know, wouldn't even come close to getting this answer, but here's the exact answer for it. So that's the reason I'm saying that it'll never appear on a test, because everybody in that class, including the geniuses from Asia or India or wherever they come from, which they do come from there, because they teach this stuff to them at the age of 3, and they wouldn't even be able to do it probably. So anyways, I say it would never be on a test. So I say anytime anything goes off the screen of this calculator in my programs, you're doing homework, or you're doing experimentation, or you're doing some problem that's too difficult, would never appear on a test. So I'm not going to program those, okay? And I don't know who they are. There's millions of integrals that you can program, functions, you know, that you can put in here and try to do a line integral of whatever. So anyways, go to my site. You're crazy if you don't buy these programs, I'm telling you. Why would you ever study this crap? And if they allow you to have the calculator in class, then you have the calculator. What are you doing? You're not doing anything different. There's the calculator. If they allow, the calculator can do integrals and derivatives and functions and factors and expand problems and do all kinds of things in there. So you're just using the calculator, what's in there. So my programs are in your calculator now. If you buy them and load them in there, and you're going to get 5 or 6 problems more correct than the person sitting next to you, and you'll pass that class, okay? Otherwise, you can just study this stuff forever and not be able to do it and waste your time. But you have other classes too. So anyways, that's the reason I programmed it at the beginning here for me. But I got A's in calculus because of this. So anyways, good luck in your classes and have a good one, okay? See you later.